In the years when the sky was already roaring with the engines of fighters and heavy bombers, an airplane appeared in the US that looked like something a school kid drew in a notebook during class. It was nicknamed the Flying Pancake, the Parachute, and even the Skimmer. Its shape seemed so absurd. But behind this strange silhouette was a machine capable of taking off almost vertically, hovering in the air, and accelerating to speeds close to that of jets. It defied the laws of aerodynamics and promised to revolutionize the future of aviation. This story is full of contradictions: tests that ended in crashes on the beach, pilots who miraculously survived catastrophes, speed records that no one expected from a propeller-driven machine, and a tragic ending when the unique prototypes were crushed under the blades of bulldozers. Why was an aircraft that could have been a revolution destroyed? Who made the decision to turn it into scrap metal? And what remains of the audacious idea of an engineer who was ahead of his time? The answers are hidden in this story. From the first failures and mockery to flights that forever changed the perception of what a wing could do. Watch until the end, because that's where the most unexpected twist awaits you. In the 1940s, a machine appeared on American airfields that challenged the conventional idea of what an airplane should look like. It couldn't be mistaken for a fighter or a passenger plane. Its flat body resembled kitchenware more than a weapon of war, and that's why it instantly earned many nicknames. It was called the Flying Pancake compared to a parachute, and some even ironically called it Zimmerman's Skimmer. Each nickname contained a mix of admiration and skepticism. Some saw it as a brilliant breakthrough, while others saw a ridiculous experiment that would never be able to get off the ground. Against the backdrop of familiar machines with elongated fuselages and long wings, this creation looked like a curiosity. People stopped to stare at its shape. Engineers debated whether such a flight was even possible, and pilots cautiously wondered what it would be like to be in the cockpit of such an unusual machine. And yet, this strange design had something that traditional designs couldn't offer: the promise of taking off from a short runway, climbing almost vertically, and hovering in the air like a helicopter. To an observer of that time, it seemed like science fiction. In a country where the sky was already home to elegant Mustangs and heavy bombers, the appearance of a round machine, looking more like a plate, seemed like a provocation against common sense. But behind the outward strangeness lay the work of a talented designer who dared to go against the rules and created something the world had never seen before. It is from this moment that the story of the machine begins, a machine that divided opinion into enthusiastic and contemptuous, but left no one indifferent. The machine, which looked like a toy, actually concealed a bold engineering concept capable of changing the understanding of what aviation was capable of. As early as the 1930s, when aviation was just taking on its modern shape, Charles Zimmerman began to think that conventional long wings were not necessary for flight. He proposed the idea of a wing so short and wide that its area looked more like a circle than an elongated plane. For most experts, this sounded like a challenge to aerodynamics itself. Such wings were considered inefficient because they had too much drag, and the airflow detached too early. But Zimmerman saw this not as a problem, but as a chance to create something completely new. The genius of his idea was to combine the wing and the propellers into a single system. At the ends of the unusually short wing, he placed huge propellers that rotated in a direction opposite to the air vortices. This solution made it possible to reduce energy losses and make the flight much more stable. Moreover, with sufficient engine power, such large diameter propellers could generate lift comparable to that of a helicopter. In theory, this meant that the aircraft could not only accelerate to high speeds, but also hover in the air, take off almost vertically, and land in a minimal area. The idea itself seemed audacious and unrealistic. In those years, engineers tried to build machines with increasingly thin and elegant wings, striving for aerodynamic perfection, while Zimmerman, as if in defiance of all the canons, proposed the opposite: a flat body, huge propellers, and a fundamentally new scheme of movement in the air. He was ahead of his time because he saw beyond tradition. Instead of improving the conventional, he was trying to create a different path for the development of aviation. At first, his ideas were met with caution, considered more a fantasy than a serious engineering project. But the designer himself was not going to stop. He was convinced that if he could bring his calculations to life, the sky would know an aircraft that could do what was considered impossible. In the mid-1930s, Zimmerman decided to move from calculations to practice. He built a small manned machine with a wingspan of just 2 meters and equipped it with 2 compact air-cooled engines. It seemed that the plan was about to become a reality. The structure was ready, the huge diameter propellers were in place. All that was left was to get it off the ground. But this is where his first disappointment awaited him. It proved impossible to synchronize the rotation of the propellers. They constantly conflicted with each other, and the machine was never able to lift off the ground. For most engineers, such a failure would have been a reason to abandon the project. But Zimmerman looked at what was happening differently. He saw not the collapse of the idea, but an important experience that confirmed that the design worked. It just required a different implementation. Then he created a new model, a small prototype with a wingspan of only half a meter, equipped with a simple rubber motor. It looked like just a toy, but it was this toy that first proved that the idea could work. It confidently took to the air, performed a stable flight, and showed that the designer's calculations were not empty fantasies. These first steps, though unsuccessful at the start, became the basis for the further path. Zimmerman realized that the key to success lay in the constant search for new solutions and the willingness to change details without abandoning the idea itself. His small model, in a way, anticipated the future. In miniature, it did what a real flying wonder was one day supposed to do. After the success with the rubber-powered model, Zimmerman had a new goal: to prove the seriousness of his ideas to the scientific community. However, the first attempts to interest specialists at the National Advisory Committee for Aeronautics were met with a cold reception. In those years, the NACA preferred to work with proven designs, and his project seemed too bold and unusual. But time was on the engineer's side. He continued to work, accumulated calculations, and demonstrated the results of his experiments. And gradually, his persistence bore fruit. In the summer of 1937, Zimmerman was invited to the CHV Corporation, one of the leading aircraft manufacturing companies in the United States. Here he first gained access to powerful laboratories, modern equipment, and a team of specialists ready to support his experiments. In this environment, he was able to put into practice what had previously only been theory. This is how a small electric-powered aircraft, designated F-162, appeared. Its wing had a span of only about 1 meter. But for Zimmerman, it was a real breakthrough. The electric aircraft took off and held its own in the air, demonstrating that the design of a short wing with huge propellers really worked. The tests were carried out right in the hangar, and each flight strengthened the designer's confidence in the correctness of his path. For many colleagues, this was a sign that they were not dealing with a dreamer, but an engineer capable of creating real flying machines. Zimmerman finally had a chance to move from laboratory experiments to projects that could interest the military and receive government funding. His unusual idea was gradually turning into a recognized scientific fact, ready to step into the world of large aircraft. When the successes with the electric aircraft became obvious, the military also took a closer look at Zimmerman's projects. On the eve of World War II, the Army needed new ideas that could give them an advantage in the air. In the late 1930s, the U.S. Navy announced a competition for the creation of a non-traditional fighter design. And it was then that the engineer's developments came in handy. In early 1939, Zimmerman got the opportunity to put his theories into practice not in a miniature model, but in a real aircraft. This is how the V-173 appeared, the first large aircraft in the shape of that very flying pancake. Its design was surprisingly complex, despite its apparent simplicity. The frame was made of wood to reduce weight and covered with fabric. 2 Continental engines, each with 80 horsepower, were hidden under this shell. Through a system of gearboxes, they rotated giant 3-bladed propellers with a diameter of more than 5 meters. The wingspan of the aircraft was slightly more than 7 meters, and the area resembled a solid flying surface where the body and wing merged into one. The length of the machine was about 8 meters, and the landing gear was made simple and non-retractable to avoid unnecessary complications and breakdowns. The control system was also unusual. Instead of the usual rudders and ailerons, Zimmerman used elevons and twin tails. It all looked as if the engineer was deliberately breaking the established laws of aviation, creating a machine of the future. When the mock-up was first shown to specialists, many did not believe that it would ever be able to lift off the ground. But for the military, the main thing was something else. If this aircraft could really take off from a short runway and maneuver at minimal speeds, it could become a game-changing weapon. And so, the Flying Pancake was given a chance to go from an exotic idea to a combat aircraft. Before entrusting the new machine to the sky, it was decided to test it in a giant wind tunnel at the Langley Field. For the engineers, this was a moment of truth. This was where it would be determined whether the Flying Pancake could even stay in the air. The tests were surprisingly successful. Despite the skepticism, the design proved to be viable, and the project was given the green light for real flights. In November 1942, at the CH Airfield in Stratford, the experienced pilot Bungayton first took the V-173 into the air. The machine took off unexpectedly easily, and the spectators experienced a mix of delight and disbelief. What was considered an engineering fantasy had taken to the air, but the joy was quickly replaced by difficulties. The power of the two engines was clearly insufficient. The aircraft could take off, but the engines were working at their limit, and the slightest failure led to an emergency. Several times, one of the engines failed right in flight, and the pilot had to make an emergency landing. The most dramatic incident occurred on a sandy beach. The machine, having lost control, flipped over on its nose. It seemed that this was the end, but the design proved to be so strong that the Pancake survived. There was no serious damage, and the pilot escaped with a minor scare. The test pilots noted other difficulties as well. Due to the large angle of attack, the view from the cockpit was extremely poor. Taxiing and takeoff turned into a risky test, but at the same time, the aircraft amazed with its capabilities. The takeoff run was only a few dozen meters, and with a strong headwind, it would take off almost vertically, like a helicopter. The maximum speed remained low, just over 200 km/h, and the ceiling barely exceeded 1,500 meters. But even then it became clear that this machine could do what no other could. The experience with the Flying Pancake was only a prologue to a much more ambitious idea. While the V-173 was demonstrating its capabilities, a new project was already being born within the CH company, a project that was destined to change the understanding of military aviation. This aircraft was designated XF5U1 and immediately became the center of attention, because its calculated characteristics seemed fantastic. The main difference from traditional aircraft was the ratio between minimum and maximum speed. Conventional fighters of those years could fly about 5 times faster than their landing speed, but the Skimmer, as the XF5U1 was nicknamed, promised to exceed it by more than 11 times. Theoretically, it could accelerate to 740 km/h, and at the same time slow down to 32, remaining controllable and stable. For the pilot, this meant incredible control, from a near helicopter hover to a swift dash through the sky. The designers calculated that the machine would be able to take off from short runways, operate in conditions where conventional aircraft would not have enough runway, and at the same time compete in speed with the best fighters of its time. Add to this the ability to maneuver at low altitudes and perform tasks that had previously seemed impossible, and it becomes clear why the project was immediately dubbed the fighter of the future. Its appearance resembled an improved V-173, a flat body, 2 tails, and huge propellers. But inside, completely different technology was hidden. Powerful engines, a complex synchronization system, new materials, and structural solutions capable of withstanding loads at speeds where the early Pancake would simply have fallen apart. It was a bold step into a world where the line between airplane and helicopter was gradually blurring. When the calculations looked flawless, reality again made itself felt. At low speeds, the XF5U1 began to behave unpredictably. The angle of attack increased sharply, and the machine began to vibrate so much that the structural integrity itself was at risk. It seemed that the unique design was capable of destroying the aircraft even before it could prove its strength. The engineers were looking for a solution, and it was then that one of the most unusual ideas of the project was born, the so-called unloaded propeller. This was not just a propeller, but a masterpiece of engineering. Its blades had a complex curved shape and a wide base that was attached to steel shackles. The system was connected to a swash plate, which allowed each blade to change its pitch cyclically, that is, in a circle, depending on the position of the propeller. This device made it possible to dampen vibrations, redistribute the load, and maintain stability even in modes where conventional propellers would have long since failed. In essence, it was a symbiosis of an airplane propeller and a helicopter rotor embodied in one system. The design was so innovative that the very idea of an unloaded propeller was perceived as a separate invention, no less significant than the aircraft for which it was created. These propellers became the heart of the machine. Without them, the XF5U1 would never have coped with the vibration and would not have reached its stated characteristics. But at the same time, they turned the project into an even more complex and expensive one. The deeper the engineers delved into the details, the more obvious it became that the price of a breakthrough into the future would be enormous. To turn Zimmermann's idea into a full-fledged combat aircraft, it was necessary not only to defeat vibrations, but also to make two powerful engines work as a single unit. This is where Pratt & Whitney, a leader in engine manufacturing with the experience and technology that CHV lacked, came to the rescue. It was Pratt & Whitney specialists who developed a complex synchronization system for the two 4-cylinder engines. They created gearboxes with several stages and clutches that allowed each engine to work independently, but at the same time, rotate the common propeller drive. If one engine overheated or failed, the pilot could turn it off, and the second one would continue to pull the machine without catastrophic consequences. The fuel system was no less of a breakthrough. The XF5U1 required engine power, even in modes when the aircraft hovered at huge angles of attack, almost vertically. In such conditions, conventional fuel supply systems would fail. Pratt & Whitney designed a fundamentally new system of pumps and tanks that ensured stable engine operation even when the machine behaved like a helicopter. This union became an example of how a designer's bold idea and the engineering power of a large corporation can unite for a single purpose. Without Pratt & Whitney's help, the project risked remaining a beautiful but unrealized concept. With their support, the skimmer had a chance not only to take off, but also to demonstrate characteristics that put it on a par with the most ambitious developments of its time. In the summer of 1945, a machine that the engineers had been waiting for many years rolled out of the CH Company hangar. In front of them was the XF5U1, the very fighter that had already been nicknamed the Skimmer within the firm. Its appearance was both familiar and frighteningly new. The flat body with two tails and huge propellers seemed like a step into another dimension of aviation. But despite the prototype's readiness, there was still a year and a half of agonizing refinements and checks ahead. Every single component had to be perfected, eliminating minor but critical shortcomings. The new propeller engine group required break-in. The fuel system was tested on stands, and the structure underwent endless strength tests. All this delayed the project, turning the wait into a test for the team. The military was waiting for results. The designers worked at their limits, but the skimmer was still chained to the ground. It wasn't until January 1947 that the moment arrived that had been worked toward for almost 10 years. An experienced pilot took the machine to the runway and accelerated it to the roar of the synchronized engines. The propellers, with the diameter of a 2-story house, lifted the body into the air that had recently seemed like an absurd fantasy. The XF5U1 made its first flight, and it became clear that the impossible was possible. For eyewitnesses, it was an event of a special scale. The aircraft, resembling a giant disc, not only took off, but also showed controllability that engineers could only dream of. On that day, the skimmer ceased to be an experiment on paper and turned into a real aircraft ready to challenge traditional aviation. After the first flight, it became clear that a series of amazing discoveries awaited the skimmer. Tests quickly proved that this unusual aircraft was capable of things its creators hadn't even expected. It didn't just take off from a short runway, but could take off almost vertically, like a helicopter. The huge propellers lifted the machine up without a takeoff run, and at the right blade pitch, it could hover in place, remaining motionless in the sky. But the most amazing thing was yet to come. During one of the flights, test pilot Richard Burroughs took the XF5U1 to afterburner and, at an altitude of about 9,000 meters, accelerated it to a speed of more than 800 km/h. For a propeller-driven machine, this was an unthinkable result. This is how an unofficial record was born that made the skimmer one of the fastest propeller-driven aircraft of its time. Test pilots also noted other unique qualities. The range of speeds was amazing, from 32 km/h when the machine could barely crawl forward, to hundreds of kilometers when it competed with jet fighters. No other aircraft had such a range. The controllability was also surprising. The skimmer obeyed the pilot at extremely low speeds and at incredible altitudes, where the air became thin. Each new flight strengthened the impression that the world had witnessed a real revolution. The airplane, which had recently been called the Flying Pancake and was perceived as a joke, was turning into a machine with characteristics that could change the future of aviation. It seemed that a brilliant future lay ahead for the skimmer. But reality turned out to be much harsher. By the end of the 1940s, the CH Company was facing serious financial difficulties. It was becoming increasingly difficult to support the expensive project, which required constant refinements and tests. Every day of work on the XF5U1 cost a significant amount, and the company's management was increasingly thinking about putting an end to it. The situation was aggravated by the rapid transition of American aviation to jet engines. The U.S. Navy, which had initially funded the development, no longer saw the point in investing in a propeller-driven design, no matter how revolutionary it was. The future, as it seemed then, belonged to jet fighters, and Zimmermann's project was no longer perceived as a step forward, but as a dead end of development. In the spring of 1948, a final decision was made. All valuable equipment was removed from the XF5U1, and the unique aircraft bodies were crushed under the blades of bulldozers. They were crushed and turned into scrap metal, as if they were not engineering masterpieces, but useless junk. For those who worked on the project, it was a real blow. Years of work disappeared in a matter of hours. Only one flying Pancake, the earlier V-173, escaped this fate. It was transferred to the Smithsonian Institution Museum, where it has been preserved to this day. But the main hero of the story, the fighter of the future, was destroyed before it could show everything it was capable of. The fate of the two machines born from one idea turned out to be different. The V-173, the very flying Pancake that was the first to prove the viability of Zimmermann's idea, survived. It was preserved not because the Army needed it, but rather because of its unusual appearance and its role in the history of experiments. After the program was closed, it was transferred to the Smithsonian Institution, where it took its place among rare examples of aviation technology. Today, every museum visitor can see its rounded body and imagine how, in the early 40s, this strange machine struggled to get into the air, causing both laughter and admiration. The XF5U1 did not receive such a fate. Despite its records and amazing capabilities, it was considered unpromising in the era of jet aviation. After the project was officially closed, the unique prototypes were mercilessly destroyed. They were crushed by bulldozers and sent for recycling, as if they were not symbols of audacious engineering thought, but just metal. Not a single genuine copy of the once revolutionary machine has survived. Only photographs and the memories of those who saw it in action remain. Thus, two airplanes, born from one person, had different destinies. One outlived its time and was preserved in a museum to remind people of the boldness of ideas. The other disappeared forever, as if it had never existed, leaving behind only a legend about what the path of aviation could have been if history had taken a different turn. Today, looking at the rounded silhouette of the V-173 in the museum hall, it is difficult not to wonder what path aviation could have taken if Zimmermann's ideas had been developed. His concept of a short wing and huge propellers with the ability for vertical takeoff was a precursor to a whole field that, decades later, was embodied in machines with a shortened takeoff run and the ability to hover in the air. Designers around the world later returned to his calculations, already creating aircraft capable of landing on short aircraft carrier decks or taking off from limited areas. In fact, his projects were the first to voice the idea that a machine could combine the qualities of an airplane and a helicopter without sacrificing speed for maneuverability. But for its time, the Flying Pancake was too bold. The US bet on jet engines, and therefore Zimmermann's projects became a symbol of how the future sometimes comes too early. Today, his aircraft is seen as a sign of an unfulfilled revolution, proof that even the strangest looking ideas can be the key to future technologies. Zimmerman's legacy lives on, not only in the museum exhibit, but in every modern vertical takeoff aircraft, be it a tiltrotor or a deck fighter. His flying Pancake reminds us that progress is born when someone dares to challenge the conventional and build a machine that most would consider impossible.